Shah, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss one more topic of Laplace transform. Okay, so let us start with the topic, that is differentiation of Laplace transforms. If Laplace inverse of f of s is equals to f of t, then f of t equals to minus 1 upon t Laplace inverse of f dash of s. That is, firstly we are given f of s, then we will do the derivative of f of s, then we will find the Laplace inverse of f dash of s, and finally we will multiply this answer by minus 1 upon t. So we will get our Laplace inverse of f of s, that will be equals to f of t. Now when to use this formula? We only have to use this formula to find inverse Laplace transform of functions such as log, tan inverse, cot inverse, etc. So whenever you see this type of functions, you have to apply this formula, right? So now let's study few examples. So we have to find inverse Laplace transform of log 1 plus omega square upon s square. So here you are seeing log. So we have to apply the following formula, that is f of t is equals to minus 1 upon t Laplace inverse of f dash of s. So firstly let us write our f of s, that is our question. So it is log 1 plus omega square upon s square. Now let us simplify this. So it is equals to log of s square plus omega square upon s square. Fine. So now log a upon b will be equals to what? Log a minus log b. Now we can bring this 2 over here. So it will be finally f of s is equals to log s square plus omega square minus 2 log s. Now let us find the derivative in order to apply this formula. So f dash of s will be equals to derivative of log will be 1 upon s square plus omega square. Apply chain rule, so derivative of s square will be 2s minus 2 times. Again derivative of log s will be 1 upon s. Right? Now let us apply Laplace inverse on both the sides. So Laplace inverse of f dash of s will be equals to 2 times Laplace inverse of s upon s square plus omega square minus 2 times Laplace inverse of 1 upon s. Now let us put the values of Laplace inverse of these two functions. So finally Laplace inverse of f dash of s is equals to 2 cos omega t, because s is there in the numerator, so cos will come. So 2 cos omega t minus 2, right? Because Laplace inverse of 1 upon s will be equals to what? 1. So finally put this value in this formula. So our final answer of f of t will be equals to minus 1 upon t 2 cos omega t minus 2. So basically what we have done, firstly we have written our f of s, then we have found out its derivative, then applied Laplace inverse on both the sides. So whatever is the answer, we are multiplying finally by what? Minus 1 upon t. Okay. So this is the way to solve the examples having log, tan inverse, cot inverse, etc. So now let us go to our next example. We have to find inverse Laplace transform of tan inverse 2 by s. So now again we have to use the following formula, that is f of t will be equals to minus 1 upon t Laplace inverse of f dash of s, because we are given tan inverse. So firstly write down your question, that is f of s, that is equals to tan inverse 2 upon s. So find its derivative, that is f dash of s. So now we know the derivative of tan inverse of x will be what? 1 upon 1 plus x square. So here the derivative will be 1 upon 1 plus 2 by s whole square. Now apply chain rule in this. So minus 2 upon s square will come, right? Now simplify this. So we will get s square upon s square plus 4 into minus 2 upon s square. Now this gets cancelled out. So f dash of s will be equals to minus 2 upon s square plus 4. Now we have to find Laplace inverse of f dash of s. So Laplace inverse of f dash of s will be equals to minus 2 times Laplace inverse of 1 upon s square plus 4. So the inverse of this function is minus 2 outside, and the inverse of this is 1 upon 2 sine 2t, right? So 2 and 2 will get cancelled out, right? So final answer of f of t, we just have to multiply the given answer, right? This answer by 1 upon t. So minus minus plus, so 1 upon t sine 2t is the answer of our given example. Now let us move on to our next example. So we have to find inverse Laplace transform of cot inverse s plus 1. So again, looking at this cot inverse, we have to apply the following formula, that is f of t is equals to minus 1 upon t Laplace inverse of f dash of s. Firstly, let us write our f of s, that is the question cot inverse s plus 1. Do its derivative, that is f dash of s. So derivative will be minus 1 upon 1 plus s plus 1 whole square, because we know derivative of cot inverse of x will be equals to minus 1 upon 1 plus x square, right? So we have obtained this. Now let us find Laplace inverse of f dash of s. So minus will remain outside, Laplace inverse of 1 upon 1 plus s plus 1 whole square. Here we have s plus 1, right? So we have to apply first shifting theorem. So firstly remove this and write e raised to minus t. This minus will remain as it is. Now what is remaining? 1 upon 1 plus s square, so answer will be sine t. So this is our Laplace inverse of f dash of s. Now we just have to multiply by 1 upon t to find our f of t. So f of t is minus, minus will become plus. So final answer will be e raised to minus t sine t upon t, right? So this is our final answer. So now let me give you a brief idea about Laplace transform. So firstly, the definition of Laplace of f of t is what? Integration 0 to infinity e raised to minus st f of t dt. This formula we have used to prove many formulas, right? Then you have to remember the 8 formulas. I will generalize in a short statement. Laplace of 1 is what? 1 upon s. Now whenever you have s plus or minus a, you have to write e. Whenever in the numerator, right, you have e, what will come? Sine. Whenever you have s, cos will come. Whenever you have s square minus a square, these two functions will be what? Hyperbolic functions. Then you had first shifting theorem, right? So in this, what you have to do, whenever we have to find Laplace of e raised to at into f of t, you have to remove this e, and in place of s, you have to put s minus or s plus e, right? Then what is second shifting theorem? These are the basic and very important theorem. Whenever you have Laplace of f of t minus a ut minus a, right? Then the answer will come as e raised to minus as f of s. So whenever you have unit step function, you have to apply second shifting theorem. Then the other two formulas that you have to remember is Laplace of unit step function, that is e raised to minus as upon s, and Laplace of Dirac delta function, that is delta t minus a, will be what? E raised to minus as. And the last theorem that you have to remember is convolution theorem, right? So Laplace inverse of f1 of s into f2 of s will be equals to what? Integration 0 to t f of u g of t minus u du. So these are some important theorems which I have given a brief idea, and also go through all the formulas very carefully. Okay. So I hope you have understood throughout the session. Thank you for watching.